This conference will now be recorded.
Okay.
Yeah, Chris, this is Charlie. I agree. The idea um, would would accelerate progress, and one format would be that each task group would develop a proposal that is presented to the larger group for approval.
Yeah, exactly. That's exactly the approach I think would make sense. So, with that in mind, I would like to review with you all what I consider the opens to be. Um, I sent them an email, but I'm just going to go through them right here. The first one I think is is fundamental, and it's the one that I think we've really struggled with. So Kathy and Zakir and I have presented data for our vibration analyses, but we have a challenge for determining, is that right? Is it relevant, etc. So I think the first area that we absolutely have to make progress on is this. And the key word being here for greatest relevance to the hard drive dynamics disturbances. Um, you can look at vibration in lots of different ways, or you can look at any signal in multiple different ways. But trying to establish how and why it's related to dynamics disturbance, I think is key here. And that will play a big role into the paper. The next one, with which we've struggled, is repeatability. I think in our last meeting, Daniel shared where he was showing some challenges with values being, you measure it a few times and getting the same result. And that's directly tied to the analysis mechanisms. Although they can be complementary and independent, meaning one could say, hey, here is a metric that we're finding is repeatable. Is it relevant within our analysis to the dynamics disturbance? Based on those, the third one I have there is, I think we may need to look at the way we're taking measurements of RV and LV to make sure that we're delivering on the two above. That might mean that we have to move the sensors. Again, we won't know that until we get further through the above, but I think I've seen that thus far. I mentioned that in our phase 1 paper, where it's just acoustics, we provided a mechanism for reporting the acoustical data. And we don't have that for the current phase, meaning whatever the metric is that or the values that we come up with for vibration, we don't have a way of presenting them. Maybe it's PSD, maybe it's, as Charlie presented last time, a different means of outputting the vibration. Then what's really, and I mentioned this to Bo when he first proposed this, really challenging is then how do we aggregate the acoustical and the vibration together? Even if we do accomplish the vibration, we know that it doesn't exist in isolation, that the two play different roles in the frequency regime, but they play together, and also how to present them. They both have different forms of contributing. And then finally, or the last two, in our previous paper, although we didn't show absolute thresholds, we did show a mechanism for communicating problematic acoustical disturbances. Ted had provided a combination of green, yellow, red zones as a means for, if you're working with a hard drive manufacturer and they say, you're in the red zone for your acoustics, probably means something needs to change. So that does exist in our phase 1 paper, but given the previous, we would need to figure out what that looks like for vibration and acoustics. And then finally, the write-up of the paper. That can progress, I think, using placeholders for the above. So here are 7 opens that I identified that need to be addressed. And what I'd like to do is identify some, call it task group, as Charlie mentioned before, or work stream, as I've heard mentioned in other OCP forums, owners for each of these, with the idea that, you'd work with colleagues here, maybe other colleagues, to provide updates in our subsequent meetings in each of these 7 areas. So I would like to start there, unless someone sees a big other gap that I'm absolutely missing, or says, you know what, that thing that you're pointing out as an open isn't really an open. Any comments on this before we try to assign some owners to these?
Chris, I have a suggestion that the vibration repeatability simply be expanded to repeatability to include both acoustics and vibration. That's first. And then um, the second comment is with respect to the thresholds. Um, I would think that, I would hope that the thresholds would be flexible with respect to uh, each supplier integrator combination, but perhaps the format would be consistent. In other words, the red, yellow, and green zones would exist, but correspond to different magnitudes depending on the product application. So those are my 2 comments.
And Chris, regarding the thresholds, I did present some limits that we had as a reference for some time. I could share those as a starting point if needed. And those are the limited rates we had on the rotational vibe and the linear vibe.
Okay. How about this? That is a starting point, and I apologize for maybe misstating that. I think the better word would be we have some starting points here, but however, need to combine them to go further. Okay, and
Chris,
any other comments?
I think I would put the potential vibration sensor updates kind of at the tail end of the vibration analysis and repeatability, because I think once you start getting into measurements and you find that maybe they aren't satisfactory, at that point in time, you might start to think about that. Otherwise, you wouldn't have a significant amount of information to help guide you in that direction.
Okay. Okay. Yeah. Got you.
And I think I would throw out one more item. So I've had a couple emails out about calibration correlation of the surrogate so that we all measure roughly the same thing. And I kind of stumbled on a couple of the different techniques. But I have a bunch of background data now on our WD surrogate, and I think that's I don't know if it fits into the repeatability portion of this, but certainly if you're not measuring the same thing because of errors in the surrogate, then that will certainly have an impact on thresholds and whatnot. So
Yeah.
I'm not sure exactly where that would fall.
I think you're right, David. That topic would fall under repeatability. One in my mind is how important is the calibration of mass or the overall mass um, with respect to repeatability across different surrogate units? That's an open question, and I think it is related to repeatability across the surrogate units.
On the repeatability, Chris, I don't know if I'll be able to lead it, but you can definitely put me on that one. I've got we still haven't got our surrogate built up yet. Our model shop has just been slammed. So I'm in line still.
Gotcha.
But one of the things I think we really need to focus on here, and I'm not sure of how the other, the people who have been doing a lot of work on it, if you're doing repeatability in a system or repeatability on a shaker, because to me, repeatability in a system, I mean, the system has enough variability in it with the fans and the carriers and everything else. I think we really need to start at, putting this thing on a shaker and then checking repeatability there, because I don't know. I think there's a high chance that the variability of the system is much greater than the variability of the surrogate.
Ted, I'd second that big time.
Yeah, I can talk to that more at another time. So we've
Yeah,
looked at that, and
you're probably right.
Okay, very well. So what I'd like to do so that we can accomplish the subtask teams, again, the intent, keep in mind, is, or the two intents. I don't want for any of us to have to do too much. It's very easy in these industry forums where we're basically volunteering our time for one person to take on a lot. And what I want to make sure that we've got sufficient coverage that we can, work together on a certain area and deliver to that. The other thing is, I do want to, in our next meeting, for example, come back and say, okay, here's where we are. Maybe it's not done, but have a status of here's what we found, here's what we're recommending right now, and here are the next steps. So with that in mind, I guess here would be my first question. The vibration analyses and vibration repeatability, should they be combined into just one, vibration thing, or can they be kept separate so that we can, two different groups could work on those? What are thoughts?
I think they're related, but it might be best to keep them separate just with the way you have them described. So vibration analyses, we're talking about just what methods we're using to look at the data, right?
Oh, that's right.
Yeah. But I mean, that does somewhat influence repeatability if you want to look at repeatability of overall broadband versus peaks or anything like that, then there's, I guess, some cross communication there.
All right. So, yeah, so maybe let's, for the
Hey,
time
Chris, I would
being,
I
go
would
ahead.
throw out in the repeatability process what Ted brought up about using a shaker and trying to eliminate the chassis as a confounding portion of that's in my experience really true. But if you're going to look at the analysis, you have it. I would think that you might want to make it more complex and start looking at the real life benefits of in chassis measurements, because then you may have to decide what is a good measurement, because now I have a lot more noise in the system. I've got a lot more modes. I've got all kinds of spectra, and that's really where the rubber meets the road.
Yeah,
Yeah, I would agree. I would agree with that. Ultimately, the purpose of these surrogates is to take measurements in a chassis or a chassis prototype. Uh, so if the chassis really adds that much variability, that relieves the burden of accuracy for the surrogate. Um,
So the chassis do add a lot of variability. I think it's a good idea to look at variability in situ during testing, but so kind of back to where we talked maybe 2 months ago on the kind of calibration validation studies with a shaker. I think those are pretty important to look at to compare surrogate to surrogate so that you know that this then chassis variability study is looking at good data rather than data that is already confounded by too much surrogate variability.
yeah, I agree. We should do both. Um,
Yeah,
Yeah,
they're both
yeah,
good. I think one informs the other.
yeah. I think it's good to, look at like the surrogate on a shaker, just okay, our expected repeatability is within 1 dB, and then to also put, do it in a system of, replacing the carrier, putting the carrier back on, doing everything, completely taken out, put it back in, do that quite a few times, and just get some idea. Because if we're finding that the repeatability is 4 dB, 5 dB, and then we're going to sit there and try and split hairs on a spec, well, I mean, we really need to know what essentially the gauge R&R is on that,
Yeah.
so that we have some idea, going
Yeah.
forward.
And I could just, I don't know if it's the time for, I'd like to contribute it that we've run some of those studies here, so I have some results I could share already. But we're planning on running a few more.
Fantastic.
Okay.
and yeah, for the record, this is Charlie. I am interested in contributing to and perhaps even leading the variability effort.
Okay. Well, excellent. Let me get the names of everybody who would like to be in that work stream. So we got Ted and Charlie thus far.
And Dave.
Dave, okay.
This is Kathy. I think since I have output some report according to the OPIS topic A and B, and I have no more plans to do more work on these two topics. But I will volunteer to take part in this work stream, and I hope to take part in the discussion and email communications to track this item.
Okay. So are you saying you would like to be in this work stream or not?
Yes.
Okay.
Yeah. And it seems that people think we should separate system repeatability and standalone repeatability. So should we depart the OPIS B into two topics?
You know what? I will leave that up to the group. I think, yeah. So the intent here would be that, break it up into a smaller group. And then you all can meet together to say, like, how are we going to go about this? And then agree. Maybe it is what you're saying, but I don't know that tonight I want to say we should break it up yet. That may be what you decide, and then we can come back and say, okay, now that we've got this, then let's look at that.
And I have some points about the repeatability. I agree with Dave and Charlie that the repeatability is caused by both the tool, the surrogate, and the object that we are measuring, i.e. the chassis and operation of the tester. I think all the three items add to the total repeatability of the measuring result. So I suggest that when we look at repeatability, we can we can look at this problem into the from the 3 points, from the three parts.
The three
And
parts being the surrogate, the chassis, and then the test setup. Is that what you're saying, Kathy?
yes, and the latter 2 parts is they are similar to Gardner concept, and the first surrogate repeatability can be revealed from standalone shaker testing.
Yeah. Okay. Next. Okay. Ladder.
This
Okay.
is Jennifer from Lenovo SP
Yeah.
team.
Hi, Jennifer.
Yeah. I'm very intrigued about the sensor locations. I think the based on the definition of the RV, different position of the sensor may have different values. May I have I would like to design some test case to verify this.
Okay. So as part of that, I think that would be included in the repeatability. Would you like to be part of this work stream?
Yeah, it's my pleasure.
Okay. Very well. Anyone else on this area?
Chris, if you want to add me in there.
Okay. Now I would like to determine an owner. Charlie, you said that you'd be willing to lead. Did I capture that right? And is someone else, like to state their interest in leading this work stream?
Well, you did capture correctly that I'm interested in leading.
Okay.
Yeah, and in regards to the shaker testing, I can just send something out and we can talk about that. We've revised
Right.
our setup.
So I appreciate everyone offering their time. So here's the way that I request. However you want to work together, lead, etc., that's up to you all. The 2 requests I had before, as I mentioned, are when we meet next in June, then we have a status update with next steps and findings so that you can share with the broader group. And the next steps is kind of the most important part, so that we have a convergence time frame. I'm not going to ask for next steps right now. And that however you all want to go about it, electronically, via Zoom, etc., that's entirely up to you. Does that sound reasonable?
Yeah, that sounds good.
Okay, very well. Thank you all. All right, reporting mechanisms.
If we want to back to point A, Chris, I can lead that.
Okay.
Yeah. Just so that we don't skip that.
Is anybody else would like to work with Daniel on?
Yes, Chris, can I put my name on that, please? Zakir.
Yes, Zakir. Yeah. Anybody else? Okay.
And Chris, on the threshold side, I mean, I could send out the starting point on the thresholds as it stands right now.
Yeah, so Yeah, I'm interested in that, the presentation of those data. Um, would you be interested in leading that, Sakir?
Sure, I can do that. I can also check if other drive manufacturers have a similar spec or not as a starting, sort of combining, but I'm not sure at this point.
Yeah, I can also help contribute there, Chris. I still need to talk to our legal team about how much I can share.
Okay. I think I'm so I think the reporting mechanisms, let's for the moment defer that until we see better what we have from the vibration. I think that makes sense.
Yeah,
On above.
I think that would follow, I guess, both points A and B on what gets reported.
Right. I also think this one kind of has to wait a little bit, the aggregation, because we don't know yet what we have.
In the paper, is it the white paper you're mentioning about, or is it a publication in a conference?
No, I'm sorry. This would be for the OCP paper.
OCP white paper, okay.
Yep.
Okay.
So we have made progress on that.
Yes.
Last summer, several of us had started on it. Charlie and Sakir and Kathy and others had contributed to it. I do think that can proceed. The way I like to look at papers is an outline, and then you start to fill in, and even if you don't have the technical aspects,
Okay.
you can kind of get a flow for it. I'm sorry, I feel like I'm cutting you off, Sakir. Please go ahead.
Yeah, I was going to say that, I mean, as we get new updates or data, I could be updating the existing document just as a placeholders. I don't think we're finalizing at this point. We'll just be capturing the ongoing progress and
Yep,
then
that's right.
eventually looking back to it. Yeah.
That's right. It is not finalizing it at this point. Yeah, I should have.
So I'll be capturing some data as it becomes available, or some approaches or decisions.
Capturing the organization of thoughts.
Yep.
Outline for gaps, primarily. So Zakir, you're willing to lead that, or?
Yes, I can volunteer to be updating at this point, and eventually you need to bigger team to finalize it, right?
Yeah, I'm glad to work with you on that. I also. Is there anyone else who would like to continue the progress on the paper?
So Chris, I'm not sure I'm formally volunteering, but I feel that I'm joined at the hip with Sakir. So I've been supporting him mechanically on this surrogate. So I'm sure I'll be working with him on a number of issues.
Thanks, Dave. Appreciate it.
All right, anybody else? Okay, very well. So we have owners and we have contributors for each of these areas. We'll publish the minutes from this. As I said, in our next meeting, we'll have an update from the work stream teams on each of these areas. By the way, this neither is preclusive of other work streams being relevant. If someone says, something else needs to happen too, we can of course discuss that. And as ones converge or are no longer needed, we can call those closed. Ultimately, the objective is to output both the CAD and the paper for the usage of this so that companies around the world can use the combined surrogate for dynamics measurements and then be able to communicate either with the host enclosures and or with the hard drive manufacturers or others about disturbances so they can make wise decisions about their products. All right, with that being where we are, if you all are okay with it, what I'd like to do is see, I think some folks had prepared some content to review today, and if that's the case, I would like to capitalize on the fact that we're already congregated to discuss that. So if anyone's prepared something to discuss, let's go ahead and bring that up.
So Chris, I have an analysis of Zakira's surrogate in light of the concept of calibration.
Uh-huh.
So maybe, I have to remember how to
Do the share.
Yeah. I don't remember if it's in settings. No. Oh, there we go.
It's
Never mind.
should be at the bottom of the
Yep.
screen. Yep.
Let's see. If I'm sharing a window.
You are sharing your screen that shows all of us right now.
Okay, so Zakir sent out his surrogate, and I had a couple ideas, several of which I had listed out into the group, and so I've been learning about this surrogate. I've done a modal analysis on it. I've done CG calculations empirically. I've looked at where the excels are to look at to put together an error estimate. So I thought let me see how fast I can go through this.
Okay. Your screen is blank right now. Or it looks like it's showing a little bit of something at the very upper left-hand corner, but then not the rest of it. So I'm not
all right.
exactly
Well,
sure.
this is the second time this has happened. Sorry, let me stop sharing and let me see if I can correctly share. Sorry about that.
Oh, no problem at all.
Okay, let's try this again. Can you see my big screen?
It is showing us again.
All right, so let me try and see if you're now seeing an Excel spreadsheet.
We are now, yes, you got
Okay.
it. Yay.
All right. Yeah. All right. So this is the modal study that I did. I divided up the surrogate into a number of points using a modal hammer. I went ahead and collected a bunch of FRFs. Here's a sample FRF in the real and imaginary domain. Taking acceleration. I did the most basic, this is called a quadrature peak pick method, which I'm really taking the peak of the imaginary response. And in this case, I'm going to be looking at Z-axis. So what you can see is there's really two modes this is about 2950 and the other one is up over 3000. About 3500 hertz. So you can see there's two big dominant modes in the response that kind of matches what the FEA was targeting. And when you look at the lower frequency mode, and I don't know how well this is going to share, it's not doing a great job right now. All right, so okay. Anyway, it's a torsion mode. Okay, nope, not going to show. All right, so first mode is a torsion mode, which is similar to the what was shown in, I'm going to move around very quickly here. All right, so here's the twist mode, 3.5 kilohertz. This is the low frequency mode. Bending mode was at 3.9. And I ended up with 2950 for the twist mode or the torsion mode and 3521 for the bending mode. So the mode shapes are similar. The frequencies are a little different. I have a little bit of insight into that. And I wanted to point out part of that insight is in the shape of this curve. This typically if you have a nice uniform material, the damping or the response will look symmetric about the damped natural frequency. It looks kind of that way with the higher frequency mode, but if you look at the lower frequency mode, it's not. So there's some nonlinearity in the lower torsion mode. And I'll move over here. So what I found inside of our surrogate, there are lumps of adhesive that are separating the top cover from intimate contact with the base. Let's see if I can zoom in on this. There are 4 relatively thick pieces of tape at this location, and then there's another big chunky of adhesive, all of which will help prevent intimate contact between the two surfaces. And I'm not sure if there's a torque spec, but for these particular 2.5 M2.5s, a torque spec of 3 inch-pounds is recommended. So we might want to say when we put these together to prevent these modes from maybe migrating down lower, that we want to make sure that we have nice contact and we have good torque. So that's kind of the spin-off on the modal, but the modal did say there are no modes below roughly 3,000 hertz.
Hey, Dave, I can kind of add to that. So that's in really good agreement with our FEA here.
Excellent. We like physics. Physics should work. CG estimations. So the technique that I use, I looked, I had talked to Zakir about using the string method, but there's a lot of wires back here. And so I did a different method. I did the weight scale method. So what you see is I calibrated the weight scale. It's 700 grams of weight. That's pretty close. It was less than 1%. I supported the wires and weighed the surrogate. This is in pounds, not in grams. And then what you see is I supported one edge and I measured the second edge, and then you can use the measurements, the 2 measurements, to calculate where the CG is longitudinally, and the same with the cross axis. So this is the technique that I used. And if you look through all the math, what it boils down to is there was a target CG that Zakir had sent me, and so using the 2 measurements, I then also came up with similar measurements, and I'm about 400 microns off in the CG from nominally where it's expected to be. So it's pretty close. Now that's a MR squared error to the inertia, but but it's actually less than 1% from where the CG location is. So it's a method. You machined your surrogate, you put all your parts in there, and where is the CG relative to some target location? And at least this way we could talk from surrogate to surrogate where we are and what we might expect for errors.
Okay. So does that mean that what does that mean in terms of, does that impact the manufacturing process, or what's the ramification, I guess?
Well, the implication is if you're looking at the linear acceleration values, it's really just the mass, right? If you want to calibrate surrogate A with surrogate B in the linear DOFs, then if one weighs the same as the other, then other than the channel errors, you should get the same answer. If you have a difference in mass, then you can have a correction factor to bring your mass back, which you could then multiply the linear. Rotary is a kind of a vastly different thing. So the rotational inertia is going to be problematic because now you've introduced different rotational inertia about the CG because it's moved, and so that gets a little bit more difficult. There is a way to check the inertia, but we've got wires on this thing, and I had proposed, using the string method for the period in order to determine the rotational inertia, and that would provide a torque equals I alpha calibration for rotation. So that's a way to do it. But when you see what happens with the Excel coordinates and that calibration, you may go, well, maybe this is kind of a not something that we may want to focus on. It's a very difficult technique in order to look at the inertia, but for the linear DOFs, it's really straightforward. It's just mass.
Good. What you just said validates what I was thinking. that really it's the rotational vibration that may be most affected. So maybe you don't have to answer this here, but thing I'm thinking about and I'm wondering about the variations that we saw the past few months. I wonder if that's owing to, I mean, the three different companies had three different folks build these. You know, could it be that, you know, they were, the way they were manufactured impacted the results? And so there needs to be an additional specification for how to make sure that doesn't happen, is I guess where my brain goes.
So I'm not sure how many of the other hard drive manufacturers or other chassis designers, if they have access to a rotational shaker. There's a Data Physics makes a really nice rotational shaker, and that would be the way to calibrate the rotational accelerations as opposed to the linear. Probably people are more familiar with the linear shakers. I know that we have access to those. That's pretty easy, but the rotational ones may be a little bit more esoteric.
Yeah. Well, I know, for example, our company can do that, but I guess I'm also curious, you know, we're pointing out that this could be an issue, and I suspected it might because rotational vibration is a calculated value.
Wait, you're playing the straight man to my next subject.
Okay. Well, yeah, I'm trying to figure out how do we get through this, but maybe you've got an answer. So,
all right. So if you look at the various sources of errors, to me, the two gross sources of errors is the hardware, which is mass, rotational inertia, and where do you put the accels? And then there are the channel errors, because you're going to be measuring. And so if you look at the hardware errors, we've just looked at mass, you know, where is the CG located? This is the next part of that, which is where are the accelerometers located? And I took ours. I don't have a optical coordinate measuring machine that was returned back to our San Jose site. But so what I did is I took a snapshot and I put it into SolidWorks and I scaled it and took a bunch of measurements with the intent of comparing the dimensions, the nominal dimensions that are used in the equations, the 120 millimeters for rotational about W, length 75, and then 92. So that's my target, is to see how close did WD end up when they positioned the accelerometers. And so not mine, sorry. The WD surrogate's 147.03 long by 101.57 wide. And using that scale in SolidWorks, and knowing that the rough diameter of the teardrop accel is 7.15 millimeters, I then located edges and then have scale dimensions. And then using those scale dimensions, I then have a measured separation, and this assumes, and I've assumed this through my entire career, that the center of the accelerometer is really where we want to measure our moment arms. So I've measured from, this is W1 to W2, 93.7 millimeters with a target of 92. That's a delta of 1.7. That's a 1.8% error in the moment arm. And that's a straight up error because it's a linear function, right? From Z1 to Z2 and Z1 to Z3, I ended up with a 5.6% error on one side and less than a 1% error on the other side. And that gives me, let's see, C2 to C3. Oh, sorry. So this is what worried me. Right now, this is a pretty significant error in the moment arm. So,
Right.
right.
Yeah.
And then the last one is the Z2 to Z3, which is this particular moment arm, and that was off 1.2%. So you have, because of the accelerometer locations in the surrogate, which should be measurable, this is pretty easy to put back into the equation to correct for these particular errors. Okay, so I think that's why this particular exercise has some pretty solid meaning, is if you can get these measurements reasonably accurately, then you don't have to use the straight up calculation in this particular formulation. You can literally use the correct moment arms or average of the moment arms. Okay, so rotational vibration. So we know if the CG is not in the same place from surrogate to surrogate, that will in fact introduce rotational acceleration errors. And now if you don't have the accelerometers in the location, that even adds to that.
Yep.
And that gets me to this errors. I found an interesting note at the bottom of the calibration certificate for the accelerometers from PCBs. And what it says down here in the bottom line is there are really regions of error in the bandwidth. In the typical region to start with, that we're probably interested in, we've got a plus or minus 1% error. And this is defined as a 95% confidence level with a coverage factor of 2, and a coverage factor of 2 essentially says 2 sigma. So the 95% confidence level at 2 sigma is 1%. So taking these values, I went ahead and said, well, if you've got 2 accels and 2 channels and you have a particular error, and I'm sure there's even a calibration error for the DT9837B, but I'm not sure if I have an estimate of that. If you're using a gain of 1, you've got a different error, by the way. So if you look at 2 channels, 2 accels, it looks like you might have a maximum of at a gain of 1 of 2.04% straight up if you have calibrated accelerometers. And if you're using a gain of 10, which I use for these measurements, you might have up to 3%. So if you look across here, the more channels that you use, the higher the error. And then when you get into the rotational acceleration, now you've got the moment arm errors, and I'm seeing something as high as potentially 8.62%, not statistically, but as a max value.
Yep. Mm-hmm.
So, and we can address some of these. I don't think you can, if you put the surrogate on a shaker and you measure the linear acceleration, the calibration by PCB is at 100 hertz. And you could go in and come up with a different sensitivity value that may be a little bit better tuned, or you can say, well, I want a sensitivity value at 500 hertz, which they say that's fine, you can do that. So if we were to establish that we want our surrogates to be better matched at 1,000 hertz, then we'd want to find a sensitivity value at 1,000 hertz instead of utilizing the one that comes in at 100 hertz directly from the factory, for example. Okay.
Yeah.
So there are ways that we can address surrogate to surrogate variation, and that all gets back to, well, how do we want to calibrate it, and where do we want to place our accuracy? Because there are these different zones of accuracy, even with the accelerometers. And of course, on a shaker, you've got another accelerometer that you have to believe in, and that's the one that you're using as a controller. And are you using a pair, or using a single? So there are interesting other factors to kind of dial in surrogate to surrogate variations. So that's my spiel for the evening.
No, that's perfect. And it actually helps me understand better kind of what I had concerns based on what we'd seen the past few months. And this helps understand, why those concerns are coming to light. So yeah, thank you very much. We have 2 minutes left. Any other comments for Dave or quick epiphanies based on what you just showed?
This is Kathy. thank you, Dave, for presenting such a professional calibration approach. My question is, are you suggesting every user to do this calibration before measuring?
Well, I think right off the bat, my suggestion would be yes, just so that you know exactly where your surrogate may sit.
Okay, and I have access to rotational shaker tool, but I don't quite understand what we need to do with it.
Well, I think that's why the working group is set up. I think that's a perfect example of something that we need to talk about if we're talking about calibrating what kind of equipment and how to set it up and how to do it. So.
Yeah, my question is if I can help with rotational vibration shaker testing, please tell me how to do it. To do the calibration or other work with the rotational shaker. Or Chris, can you give me a suggestion or description of the work?
Yeah, so I think that the work stream group that we set up earlier that Charlie will lead, you'll be in, Kathy. So I believe that Dave and the others will share that with you as part of that group. So yeah, in other words, yes,
okay.
you all will be discussing that imminently or soon.
Yeah, Charlie. Sorry, didn't mean to interrupt, but Charlie, the ball is in your court.
Yep. Okay. Excellent. Thank you so much. We're at the top of the hour. Really good discussion. Appreciate it. I feel more confident than ever that we will make real progress in the next few months towards where we need to go. And if anyone's attending NoiseCon next week up in Michigan, I will be up there and I'd love to talk with you, see you in person. So please say hi. Otherwise, we'll set up, Zakir and I will set up the next meeting and we'll send out the minutes and we'll meet up in June.
Excellent. Thank you, Chris. See you at NoiseCon.
You bet.